All right, so for this story time, we have another fellow UIC faculty, Dr. Natalie Pardy. She's an assistant professor in the Department of Computer Science, and her research area is in natural language processing and artificial intelligence. So she helps run one of the NLP labs here in the department, alongside a couple other faculty as well who are part of the lab. And she works with lots of students, both undergrad and graduate students. And she's here to chat about mostly NLP work, which a lot of it is going to sound really familiar. We did a lot of like text-based projects this semester, and while we didn't use any NLP theory, you could imagine how understanding that a little bit better would really improve a lot of the types of things we were doing. So enjoy hearing from Dr. Natalie Pardy. Okay, so here we have Professor Pardy here to talk to us about some applications of things you're learning in CS251 with respect to her research in natural language processing. Hi, Natalie.
Hi. Yeah, so I'm Natalie Pardy. I am an assistant professor in the computer science department. So I joined UIC about 2 years ago. So it's been an eventful 2 years for sure. And so my research is in natural language processing. I co-direct our NLP lab. And specifically within natural language processing, I do a lot of work in the healthcare space. So right now I have one student working on a project where they automatically detect individuals' cognitive health status based on their conversations with a human, or what we're hoping is eventually a chatbot. And then I recently have had another project where we are extracting important COVID-19 related information from clinical notes. So that's been obviously something that has started in the past half year. And then beyond that, I have some other work that focuses more on multimodal natural language processing. So combining text input with visual input and input from additional modalities. And then in the past, I've worked on creative language, so focusing on metaphor and sarcasm. So a lot of different
Cool.
fun projects. Yeah. So
Yeah, that's super cool.
so I was thinking about the way that we use data structures in our work, and we use them a lot of different ways, of course. And so two examples I wanted to focus on, I guess, are the use of stacks in chatbots, and then the use of knowledge graphs or word graphs for general natural language understanding tasks. So with chatbots, one way that stacks can be really important is to remember what actions the chatbot has already taken. So when you're interacting with a chatbot, let's say, for example, we have a pizza ordering chatbot. So the chatbot wants to figure out like what size of pizza you want, what kind of toppings you want on your pizza, how many pizzas you want, stuff like that. So what would be annoying would be if the chatbot repeatedly said, what size pizza do you want, even after you told it like you want a large pizza. So we can use a stack to remember what states the dialogue has, the chatbot has already gone through. And that way we can also figure out what was said most recently, or if there's a miscommunication, we can go back a little bit further and we can see, like, before we started trying to clarify what is being discussed, what were we trying to do? So the way that we do that when we implement a chatbot is we create a dialogue manager. And so in that dialogue manager, we maintain a dialogue state tracker. And then we also implement a dialogue policy, which makes the decisions of what to do next. So within the dialogue state tracker, we can have our stack that just goes through the different dialogue states that have been used so far. So if the chatbot asks, what size pizza do you want? We go ahead and push get pizza size onto the stack. It proceeds further. It asks, how many pizzas do you want? We push that on and so forth. So we basically end up with a representation at the end of things that shows what we've done so far. And then our dialogue policy looks at that and it says, you know, based on what I've seen, I should probably ask what toppings and not what size pizza the user wants.
Cool.
Yeah. So that is the chatbot example that I had in mind. And then I also mentioned the use of WordNet, or more generally, semantic networks or knowledge graphs. So WordNet is a resource that we use for a lot of different natural language processing applications because it helps us perform natural language understanding so we can better understand and interpret what is the meaning of this document that we have received. So the way that WordNet is structured, and you can browse it online if you search for it, if you want to play around with it yourself, is basically you have a word. So let's say we have the word dog. The word dog is going to be connected to a bunch of other words, and it's going to be connected to those words based on different aspects of its meaning. So there are some words that are like more specific versions of dogs. So like a poodle or a pug, those would be more specific versions of a dog. So those would be hyponyms of the word dog. And there are a whole bunch of different linguistic terms that are used to describe these different relationships, and I won't go through all of them right now. But there are things like that. So those are more specific categories. There are also more general terms. So animal would be a more general term. So that would be higher than dog in the like WordNet hierarchy. So it could be connected to that as well. There are groups of related words. These are called syn sets in WordNet, stands for set of synonyms. So along with dog, you might have, something like canine or some other term.
Yeah.
So, something related to the word dog.
Right. A synonym for dog, basically.
Yes.
Not a dog that, not another word, but a word that actually is the same meaning.
Yeah. And so that's useful because then what we can do if we want to check, for example, how similar two documents are, we can look up the words in them, and then we can trace the path that would be required to connect the words in the WordNet hierarchy. So if we have one document and it says, I love dogs, and then we have another document, it says, I love poodles, those documents would be considered very similar because basically you're looking up the words in the WordNet dictionary, you're tracing the path from dog to poodle, and you figure out it's a very short path. Whereas if you have two documents, one is I love dogs, one is I hate spaghetti, then it's going to be much harder to find a path connecting those things. And so those documents are less similar to one another.
Oh, that's really cool. Yeah.
Yeah, so there's a lot of fun things that you can do with WordNet. So that's another thing.
And are these some of the things so you teach a class on natural language processing, like two different versions of the class, is that right?
Yes. So I teach 421, which is the natural language processing class that is open to both undergrad and grad students. And so I'm teaching that right now. And in fact, in our assignments, we've been working on chatbots, and we also had another assignment recently where students were looking things up in WordNet. And so these are both very closely related to what we do in that class. So it's a very fun class. I recommend that you check it out. So the prereq for 421 is 301, which is languages and automata. So I teach 421. I also teach 521, which is a graduate level class. And so that class is basically like an extension in a way of 421. So we take some of the topics that are covered in there, and then we look at them more deeply, and we discuss more research papers and stuff like that. Yeah.
Okay. Well, thank you so much, Dr. Party, for coming in and chatting with us. I think it's really cool for students to see after, taking 251, how it like really allows them access to a lot of new areas. So really appreciate it. Thanks so much. See you.
Yeah. Bye.